Hello, am I audible?
Yes, sir. Good evening, sir.
Yeah.
Yes, sir. Good evening, sir.
So people are joining. Let's wait for some 5 minutes. After that, we'll start this channel.
Okay, sir.
Okay, sir.
Anybody here?
Hello, can you hear me?
Yes, sir. We do.
Yes, sir.
Yes,
Yeah.
sir. Yes, sir.
Yeah. So good evening to all of you. Uh, let's start this session. I think a CT session is going on, right? I'm not wrong.
Yes, sir.
Yes.
Yes, sir.
So is it about to finish or
No, sir, it's
It will overflow because they said that they would do the practice test review and then she will conclude. But she said that we can watch it on the recorded session on YouTube.
oh, fine, fine. Okay, let me start. Okay, so just a general question to all of you. How many of you covered the week 3 content? You can
I
raise your.
did.
I will be having. Okay, so those who have completed, so you can
So
raise your.
before the session starts, I really want to like convey one thing. I am not from the mathematics background. I was from biology, and like as far as I see, like first and second week were like okay, but week 3 is getting a little tough.
Okay, no problem. So we'll discuss the things. So try to keep put some effort. Uh, okay, and we'll discuss the whatever doubt you guys have. You can discuss more on.
Okay,
No problem.
okay, thank you, sir.
Yeah, yeah. Okay, so what about others? How many of you covered the week 3 or is still going on? Whatever the current scenario, and
Sir, only two activities are left,
uh,
3.4 and 3.5.
what about others? If it's you have not done, you can simply tell me. No problem. It's not that. Yes, no.
Completed most of it. I'm graded assignment, but then I realized that okay, I might not have understood everything.
Okay. Okay, then what should we do? Should I take the doubts or should we take and should I summarize the concept of week 3?
Summarize, sir.
Sir,
That would be
summarize,
good.
please.
Sir,
Yes.
summarize.
Okay, then no problem. Let me summarize the concepts of week 3. Okay, along with some example and there are some two more sessions, right? Then we can discuss the problems and all in the upcoming session. Will that be all right for everyone?
yes, sir.
Yes, sir.
Yeah. Okay, great. Yeah.
Yes,
So let me share my screen. Okay. Can you see my screen now?
Yes, sir.
Okay, great. Okay, so till week through. Okay. Sorry. Till week 2, we have done about something, what kind of data is there, discrete, numerical, and all, and some scales of measurement and all, right? So in week 2, we have seen some visual representation, graphical representation for the categorical data and all, correct? Now,
Yes.
from week 3 onwards, we will be moving to the numerical data mostly. I mean, there will be concept of categorical data, but now we will see the things. See, till week 2, we have seen median, mod, and all right for categorical data. Yes or no? Correct. Now we will be doing the same things for the numerical data as well. In From week 3 onwards. Okay. So, what kind of variable we had? So, we have seen we had variable, right? What are the types of variable? It's a categorical, and another one is the numerical. Yes or no?
Yes,
Yes,
sir.
sir.
Under numerical, we had discrete
Continuous and discrete.
and continuous. Correct? Discrete is something which we can count, right? And continuous, which we can measure, right? Measurement is involving. Now you have seen to represent the count of categorical data and all shares of something we use, to for count we use bar chart, pie chart, and all. Correct? For the visual representation. Yes or no? in week 2. Now we will be moving for discrete data and continuous data. So there is something called histogram. Okay. So histogram is basically it's a very appropriate graphical representation for your continuous data set. Okay. Continuous data means we are going to make a beans and all and how many and all that, right? Suppose I have beans of, let's say I'm saying A comma B, right? So I'm not going to present plot that histogram. I will give you some rough idea. Okay. So what is this? Suppose so this is called the lower limit, right? And this B will call the upper limit of a class. Correct? Yes or no? Okay. And there are some terminology. Suppose I will ask what is the class mark. Okay. Then what is the class mark? Anyone?
I think the
Average of
range.
two limits.
Yeah. So basically, this class mark is nothing but average of the two class limits of a class, means average of these limits. Okay. So this means class mark will be A plus B divided by 2. Correct? Yes or no?
Yes, sir.
And what is
Yes.
the how will you identify the class width?
Excuse me, sir.
Yes.
Sir, can you please scroll up?
Okay.
Okay. Okay, sir. It's fine.
Yeah. Yeah. So what is the class width? Class width is nothing but the difference between the lower limit of a class and the lower limit of the next higher class. Suppose I have two class. Let's say I'm saying A, B. Okay. Then C, comma.
Your
Okay.
voice is
Then what?
breaking.
Sorry. Is it for everyone or it's I think
It's fine for me.
maybe I think he has some problem. You can rejoin. Okay? So yeah, so class width is nothing but the difference between the lower limit of a class and lower limit of a next higher class. Suppose this is the first class and this is the next higher class. Means let's say for example, what will be the class width? It will be C minus A. For example, your class width, let's say 10 to 19, and another one is 19 to let's say 20, right? So different. What will the class width there? Class width will be here 19 minus 10, which is 9. Right? Is this clear? Some rough idea? Fine for everyone?
Yes, sir.
Okay.
Yes.
Okay. So next one is, and you can see in the lecture, histogram is something we are making the bean. I mean continuous beans. You can say. I mean beans means bars. I mean, okay. This is A to B, C to D, and all. Okay. Now next another thing is second topic is stem and leaf plot. Okay. So what we are doing or what's the meaning of this stem and leaf plot actually? In a stem and leaf diagram or in a stem plot, what we are doing, each observation, we are going to, each observation is separated into two parts. Okay. So each observation is separated into two parts, and see, there will be key provided to you as per the, I mean, how we are going to represent. For example, suppose I'm saying, uh, stem is there, one part called stem and another part called leaf. Okay. Suppose I'm saying 7/5, then 6, then let's say 9. Okay. And next we can take any kind of observation. I mean, it's not like one more thing we have to keep in mind in stem and leaf plot, right? Each observation is already, I mean, observations are already in ascending order. Actually. Okay. Suppose I have created this, so next would be 8. Suppose 82. Let's say this is 0, then 2, then 3, then 4, for example, then 9, 2. So key will be provided to, what do you mean by key? Means how we have to interpret observation from a given stem and leaf plot. For example, I'm saying 7/5, I'm going to read as a 75. Okay. If this is the case, then what are the observations we have from this stem and leaf plot? Anyone? We have 75,
Yes, so 75, 76, 79,
79, 80,
80,
82,
82, 83,
83,
84.
84, 92, right? These all are the observations we have, right? Now, if you see, all observations are in ascending order. Now, tell me what about this? Okay, I will let me create stem and leaf plot. Suppose I'm saying 0, 1, 5, then 7, then 8, 2, 3, 4. Now, tell me what are the observations we have? Yeah, yeah, go ahead.
60, 61, 65.
61, 65.
Why not 70?
Because
There
there's
is
no
no leaf.
zero right that.
No zero, yeah. So it's a, I mean, we can simply say there is no
No
observation from
leaf.
70 to 79. Yes or no?
Okay.
Got it?
Yes.
So
So,
if the,
we can write like this for an empty interval. If there is no number between 6 and 8,
hmm,
uh, if there is no 7, can so we should be writing like this.
hmm. No, thing is that, so why I represented here. Thing is that you should be know if this is the case. If suppose any stem and leaf plot is given to you, so don't take there is no leaf, then don't take 70 by mistake. Okay.
Okay.
So we have to keep this in mind. So next observation is 82,
Note this.
83, 84, 95, 96. Right? So is this clear?
Yes, sir.
Okay. Yeah. So this is something we can plot. See, sometimes we have to suppose we have been given the key observers. Let's suppose you want to do. Okay. Let me tell you something like this. This is 601.
Sir,
Then 1 second. 601. Suppose next one is 2, 3, 2, 5. And I'm going to give you key like 6/01 means 601. So what are observation? What are the observations we'll be having from here? Will be 601, 623, 645, right? So key thing is this key will be provided to you how you have to interpret the observations from a given stem and leaf plot, right? Is that all right?
Yes, sir.
Okay. Yeah.
yes, sir.
Can he be anything different? Like, could it say that if it is 601, then
Mhm.
skip 0 and just say 61?
Yeah, it can be anything, but it will be provided to you how you have to interpret the observations from there.
Okay.
Yeah.
Okay.
So
And
next,
in what scenarios do we use this kind of stem leaf charts?
stem and leaf chart. Suppose see, first of all, when we have data in organized form, okay. Mainly, suppose you want to represent your data in very standard form in organized form, right? Then it's a very helpful. I mean, stem and leaf plot. Like, see, if you see the way we are. I mean, we are no going to represent our data set in a, I mean, how we are represent, we are doing in a organized manner, right? We are doing in a
Right.
ascending order, yes or no, right?
Right.
So if this is something, so suppose from this we are able to basically when we are interested to break our data set, for example, okay, let me tell you one more thing. Suppose you have some data set of age of people, right? Okay.
Okay.
Okay. Then it's very useful, and you want to show the ages in ascending order and all. Okay. Then you can simply make a stem and leaf plot.
Would there be a case wherein we only use the left side, which is the stem, and not the leaf, in order to summarize?
Can you repeat? Can you repeat?
So,
Hmm.
I mean, I'm trying to comprehend the aspect where we are going to really put this into practical use, right?
Okay.
So I'm saying that would there be a scenario wherein we only use the stem and not the leaf in order to summarize the information? Say, for instance, I want to
Mhm.
group all who are in the range of 60 to 69 into one bucket. Then I would just use the 6 and not worry about 0, 1, 5. And if I
Okay, fine.
want to only look at 80, then I just look
Yeah,
at
I think so.
anything
I
in
think so.
80.
Then
So
yeah, I think so. Then see, correct. So you will be having some idea for this bin, how many people or how many observations are there, right? See,
Right.
generally, suppose I am giving you some data randomly, right? There is no order suppose observations are not in ascending order or descending order, whatever, right? Suppose I asked how many observations are in 60 to 69, correct? Then you have to
Right.
do the things. Suppose you have then this system and plot, you can simply tell me there are 3 observations or there are 3 people in this bucket, right?
Right.
In this area
Right.
or something like that. Okay. And suppose
Okay.
you want to draw a bar chart, something like that. Okay. Then it's very useful from here, correct? Yes or no? Suppose you want to know the what is the longest bar. Then you can simply see this in 96 will be the, I mean, for 96 you will get the longest bar, right?
Why would I get 96 for the long? I would get it for the 6, right? Because 6 has got 3. So my bar chart would be for 3 entries in the 60 series, whereas for the 90 series, I will only get 2.
Okay, okay, yeah. Sorry. I got confused with this
Right.
numbers. Yeah, correct. So those who for that stem and leaf, suppose which have the maximum number, that will be the longest part. Yeah, correct.
Right.
Yeah,
Right.
thanks. Yeah,
Okay.
yeah. So next thing is you have, if you have watched the lecture video and also there are measures of central tendency. Okay. So what are those, anyone? And what do you mean by measures of central tendency? Any thought? Any idea?
It gives central value of any data set.
Central value of any data set, correct? So,
For
but
example, we can calculate
yeah,
and
why,
we can
go
have
ahead.
a rough idea that this is the average value of this data set, or mean, median, and mode are the central trend. We can know the mean of the data set, or we can know which number separates the data set into two half, or what is the maximum frequency
Hmm.
of the
Okay,
attribute.
fine. So it will give you some central idea about your data set, right? Correct. But
Yeah.
why we are interested in a central value? Any thought for that?
To
Anyone?
predict a little bit about the data.
What do you mean by prediction? So if you
Like we
see,
can summarize that this is the data and these are the things happening in this data.
so basically this measures of central tendencies and all will give you a central idea about your data set. What do you mean by central idea? Suppose I'm saying there are 2 universities, University A and University B. Okay. And let's say I'm going to take some, let's say this, let's say 10, 20, 30, 40, and 50, and then 30, 30, 30, 30, and 30. Now tell me what will be the average of these things? It's a 30, correct?
Yes, sir.
Right? And average of this things is 30. So what are, just you can assume these are the some annual packages of some 5 random students, and same for in a university B as well. Okay. Now, rather than saying 10, 20, 30, 40, 50, you can simply say, so suppose I can simply say in university A, the average annual package is 30 lakhs. Okay. For same for the university B. So whatever, irrespective of the observations, I will be having a central idea about my data set. So this 30 lakhs will represent you will give you some central idea about your data set. You can simply take anything. Let's say in a class there are some 40 students of let's say class 12. Okay, then you can calculate the average marks. Yes or no? If you are calculating the average marks, suppose there is an analyst or you are going to represent your school somewhere and all, so you can simply say the average marks of my class is, let's say, 80. Then by this 80, someone will get the idea, yeah, students are very good. I mean, performance of students is good, right? By knowing the just 80 rather than marks of each student. Yes or no? Correct?
Yes.
Are you getting the idea? Okay.
Yes.
Okay. So for this, there are some 2 to 3 measures of central tendency. First one is the mean. So mean is defined as nothing but I think it's a very simple thing. It's nothing but addition of summation of all the observation. Xi means let's say you have observation x1, x2 up to xn, n observation. I will go to 1 to n. Addition of all the observation divided by number of observation. This is something we can calculate the mean. If in case we have given the frequencies, okay, frequencies for each observation, okay, then formula for mean will be it's going to little bit change. Summation of fi xi divided by summation of each fi. Fi means addition of all the frequencies. Okay, so why we are multiplying with the frequency? It's a very simple thing. Suppose I have observations 1, 2, 3, 4, and 5. So what will the mean of this data set? It will be 1 plus 2 plus 3 plus 4 plus 5 divided by 5. Yes or no? Addition of all the observation divided by number of observation. We have 5 observations. So it
Yes,
will
sir.
be 5, 4, 9, 3, 12. So 15 by 5, which is 3, right? Now, suppose in case I'm saying you have given 1, 1, 2, 3, 2, then 4 and 4, correct? So you can see here, what will the mean first of all? Okay, just tell me the basic formula. We are going to add all the observations, right? So it will be 1 plus 1 plus 2 plus 3 plus 2 plus 4 plus 4 divided by 3 to 5 to 7, right? But if you see, 1 is occurring how many times? 2 times. 2 is occurring how many times? 2 times. Similarly, 4. So rather than writing this, we can simply say 2 into 1 plus 2 into 2 plus 3 plus 2 into 4. Yes or no?
Yes, sir.
Correct. So now if you see here, so this is something same as this is Fi, F1 first observation, then F2 second observation. Then is this is something we can simply say 1 into 3. Similarly, F3 into X3, then F4 into X4. And if you see how many times these are the how many, okay, what are the total frequency? If you see 1 is occurring 2 times, 2 is occurring 2 times, 3 is going to occur 1 times, and 4 is occurring 2 times, correct? So sum of all, okay, so if you see, this is the X size, each observation, this is the Fi frequency for each observation. So summation of Fi is 7, right? The same 7, correct? So this is the clear. Is this clear to everyone or any doubt? Yes,
No
no?
doubt, sir.
Yeah.
So can you please repeat it?
Which one?
From yes, summation of Fi.
Okay, tell me how we are going to define the mean. Mean is nothing but addition of all the observation divided by number of observation, right?
Yes.
If I have observations 1, 2, 3, 4, and 5, then this is the simplest form. I can calculate the mean.
Yes.
1 plus 2 plus 3 plus 4 plus 5 divided by 5, 15 by 5, which is 3,
Yeah.
right? Correct?
Yes. Yes. Yes.
Now, suppose I'm saying you have been given the frequency for each observation. Means suppose I'm saying 1 is going to occur 2 times, 2 is going to occur 2 times, 3 is occurring 1 times, 4 is occurring 2 times. So what's the formula for when frequency is given to you? It's nothing but mean is something you can calculate. Summation of Fi into Xi divided by summation of Fi. So Fi means frequency for each Xi. So here you
Okay,
can
so
see
we will divide it by, we'll also count the number of time 2 appears or 1 appears.
number of 2 appears.
Where we, in the denominator, for example, 2 appears 2 times, so we'll have to count 2 for 2 times.
Yes, yes. See, we have to add all the frequency. See, this is the frequency for 1. This 2 is frequency for this 2. This frequency for 3. And this is 2. This is the frequency for 4. It means if you see this observation, 1 is occurring 2 times, right? This
Yeah,
2
so
is
okay,
occurring
so
2 times. 3 is occurring only 1 time. 4 is occurring 2 times, right? So we can see
Yes, sir.
if you have observations, suppose you have large number of observations, then it will be little bit difficult to add all the observations, right? So it's a very good approach. We can multiply by the frequency and divide by summation of frequency. You can see we are going to
Yes.
get the same thing, correct?
Yes, sir, got it.
Got it? Yeah, fine. So next one is something called median. Okay. So median, what is the definition of median you guys have done for categorical data in week 2? Anyone?
Now, median divides any data set into two parts.
Two
Mid
parts, right?
value.
Yeah, it's basically mid value. Means see, this median divides the data set into two equal parts. Okay. So basically, to know this, to calculate the median, what we have to do, we have to arrange the data in ascending order, right? We can do in
Yeah.
ascending or descending. Okay. So thing is that suppose okay, so there are two formula. What about if number of observations n is even and n is odd? Okay,
Odd.
before going to this, suppose I'm saying I have observations 1, let's say 2, 1, 4, 3, 5. Okay, tell me first what should be the first approach? I have to arrange in ascending order. Then it will be 1, 2,
2, 3, 4,
3.
5.
Correct. What will the median from here? Middle
3.
observation. So middle observation is this 3. Okay, except these 2, right? So median is 3. Now tell me if I have one more observation, let's say 6. 1, 2, 3, 4, 5, 6. Now tell me, so here n is odd, right? N is odd means number of observation is odd. Here n is even. Correct. So tell me what will the median? See, if you erase these 2 and these 2, so middle, I mean here you don't have a single number, you have two numbers, right? 3 and 4. So which will be the
Yes.
median? So median is nothing but average of these two. It will
Yes,
be 3
sir.
plus 4 divided by 2, which is 3.5. Okay, so there is one formula in general formula. What is that? If n is odd, okay, if number of observations is odd, then how will you calculate the median? So median is nothing but for in case of n is odd, so it's the n plus 1 by 2th observation. Okay. So what? Okay. For this case, if you see what is the n? N is 5. 1, 2, 3, 4, and 5. Right?
Sir.
Correct.
Yeah.
So if you see 5 plus 1 by 2th observation, which is 6 by 2, that means third observation. Right. So what is the third observation by the data set which is already in ascending order, which is 3. Correct. Yes or no?
Yes, sir.
Correct.
Yes, sir.
When n is even, right, then median is nothing but it's the average of, you have to calculate the average of n by 2th observation and n by 2 plus 1th observation. Means if you see in this case, what is the n? In this case, n is how much?
6.
6,
Sir,
right?
6.
So if you see, we have to take the average of 6 by 2, that means 6 by 2th observation, correct? And 6 by 2 plus 1th observation. That means average of
Third and
third
fourth
observation
Three
and
and 4.
fourth observation. So if you see what is the third observation? 1, 2, 3. Third is 3, fourth is 4. So we have already taken the average of 3 plus, 3 and 4, which is 3.5. Is this clear? Okay. So this, we have to keep in mind this things while calculating the median. First of all, we have to arrange the data in ascending order. Okay. Is that all right?
Yes, sir. But sir,
Sir,
one
we can
question.
also arrange in descending order, right?
Yeah, go ahead.
Yes, sir. If we are given the categorical data here, one stands for something, two stands for something, and we arrange those in order, then according to this mean formula, should we take the average?
No, no, no. You can't do. If this is the categorical data, right? You first of all, for the categorical data, we cannot perform any meaningful mathematical operation, right? So you cannot do you
Average.
can average. So what you can do, you in that case, you can simply say, let's say, in middle you are
There
getting
is
A and B,
two
right?
median.
Okay, you are getting A and B. You can simply say either A will be median or B will be median. Okay.
Okay.
Yeah.
Thank you.
So next is mod. Okay, I think these are the very basic things. Okay, but let me do them. So mod of data is data set is nothing but it's the most frequently occurring value, right? Or simply I can say which occurs most frequently. Yes or no?
Yes.
For example, I am saying I have data set 1, 1, 2, 3, 4, 4, 5, 4. So what is the mod of this data set?
4.
4, right? In case suppose you have some 1, then what is the
The
mod?
bimodal.
It is
It is
So 4 and
bimodal.
1. It's a bimodal, right? So if
Yes.
this is the case, if you have 2 mods, then you can simply say this is the bimodal. If you have more than 2 mods, you will say multimodal. Okay. I think this is this clear, right? Okay.
Yes.
Then let me come to one very concept, which property you can keep in your mind, okay, which is very helpful. So that is called adding a constant, multiplying a constant, right? Suppose initially I took the example of observations 1, 2, 3, 4, and 5. Let's say I have some another 3, okay. So it will be 5, 4, 9, 9, 3. What is the median? Sorry, mean for this? 9, 3, 12, 12, 4, 16, right?
5.2.
Yeah, 16 by 3.2, right?
Yes, sir.
Okay.
3.2.
So here mean is 3.2, right? And median is how much? 3?
3.
Yes,
Correct?
sir.
And mod is also 3, right? Because 3 is occurring 2 times, correct?
Yes,
Now,
sir.
what about suppose I'm going to explain all 3 together. Tell me if I want to add a constant to all the observation, let's say that constant is 2, then what will be the mean? Okay. So before going to that, tell me if you will add the objects, what will be your new data set? New data set will be 3, right? 5, 5, 6, and 7. Yes or no?
Yes,
Yes.
sir.
Correct. What is the mean for this data set? New data set? It will be 5, 3, 8, 8, 5, 13, 13, 6, 19, 19, 7, 26 divided by 5, right? Which is 5.2. Yes or no?
Yes, sir.
Yes,
What
sir.
is the median? Yeah, tell me. What is the median?
5, sir.
What is the mod?
5.
5.
5.
Now,
5.
if you see, what is this? Can I write this as a 3.2 plus 2?
Yes, sir.
3
We
plus
can
Yes,
write
2?
sir.
3 plus 2. Now, if you see, if you observe carefully, what is this 3.2? This is the old mean.
old mean.
This is the median of old data set. And this is the mod of
Mode
old
of
data set.
old data.
Correct? Now, what about this thing? This is the constant value. Correct? So what property if you observe here? So rather than see, suppose okay, before let me tell you. So this is something. Suppose I'm going to represent new data set. Let's say this is the y1, this is the y2, this is the y3, this is y4, this is the y5, and this is the x1, x2, x3, x4, and x5. Then if you observe, if suppose this is the x bar, right, and this is the median for all data, is mod for all data. So if you see, can I simply say new mean? New mean means mean of new data set. So new mean is equal to old mean plus constant value. C means any constant. It can be plus 2, it can be minus 2. Yes or no? Can I say?
Sir, you can say.
Yes, sir.
Can I say also here new median is nothing but old median plus that constant? Yes or no? Similarly, new mod equal to old, mod of the old data set plus that constant. So far so good. Any doubt?
No,
No,
sir.
sir.
Yes.
Okay.
No, sir.
Why we are doing this case? Suppose there are some 100 students in a class. Okay. And you know the average marks of that class is let's say 80. Okay. For some reason, or suppose there is a discrepancy in one question, and class teacher wants to award let's say 2 marks to each student. Okay. Then you see, you know the average marks, initially average marks was 80, correct? Then what will be the new average? If you will award marks, 2 marks to all the students, then mean will be what? 82.
32.
You can simply say, right? Rather than adding to all the marks of all the students, then you are going to take average of you are going to take again average, right? So this property is very helpful in such kind of scenario. Okay, is this clear to everyone?
Yes, sir.
Okay, now great. What about, just take this previous data set. Suppose I want to multiply by a constant. Okay, suppose that constant is 2. I'm going to take for my simplicity. So what are the observations? 1, 3, 3, 4, 5. Okay, so I have observation 1, 3, 3, 4, 5, and mean for this data set is 3.2, median is 3, mod is 3. Okay, now if I will multiply with new data, multiply by a constant which is 2. So my new data, what will be my new data set? So it will be 2, 6, 6, 8, and 10, right? Now what will be the mean? Now tell me new mean.
The
So
6.4.
2 plus 6 plus 6, which is 14, 8, 22 plus 10, 32 divided by 5, right? So which is 6.4, right? Correct?
Yes, sir.
And new median will be how much? Which is 6. And
This
new
will be 6.
mod of new data set, which is 6.
Also 6.
Now, if you see this one, can I say 3.2 into 2? 3 into 2? 3 into 2? Yes or no?
Yes, sir.
And what is this? This is the median of old data set. Mean of old data set. This is median of old data set. This is the mod of the, this is same, right? If you see, correct? So what I can observe, and this 2 is the constant, correct? So from here, can I say, if I have I have data set of, let's say, x1, x2, xn, and this is the y1, y2, yn. So if I want to multiply it by a constant c to all the observations of old data set, right? Then mean of new data set will be, new mean will be old mean times that constant. Yes or no?
Yes, sir.
Would you agree with me? New median
Yeah.
will be
Yes, sir.
median of old data set into that constant, correct? And mod of new data set will be mod of old data set into that constant. Is this clear? Any doubt so far?
No,
Sir, can
sir.
you scroll up?
Okay.
Okay, sir. Okay. Got it.
Yeah, yeah, fine. Okay, so before going to that, before moving to next topic, there is something called extreme values. Anyone, can you tell what do you mean by extreme values? Those who have watched the lecture video, this. Just wanted to your thoughts for the
Sir,
same.
I have a doubt.
Yeah, go ahead.
Sir, what about division?
Yeah, you
If
can
we
do
divide,
anything. See, multiplication means, suppose I want to do, let's say I want to multiply it by half, means 1 by 2, correct? So it will be same, right? See, rather than c, see, this c is the constant value. This c can be 1 by 2. This c can be 1 by 4. This c can be, see, if you are multiplying by 1 by 2, that means you are going to divide by as a 2, right? Yes or no?
yeah, sir. Okay, got it.
Got it? So this is the any constant. Same here. It doesn't mean you have to add always. It can be minus value, right? This c can be minus 2 also. Yes or no? Clear? Yeah, I mean, did you get the idea, right?
Yes, sir.
Okay.
Yes, sir. Got it.
Okay, anyone can tell me what is the extreme value? What do you mean by extreme value or outlier?
Yes, sir. The last value is called the extreme value, I think.
No, you can't
No.
say in
Example
general
which is
list the
Like
slightly
last
different
example
value.
from
1,
the
2,
data set.
3, 4, up to 100.
Outliers
Then
would
the
be
100 will
completely
be the
different.
extreme value.
One second, one by one, don't.
So can we assume that outlier is a value that may impact that have heavy impact on average of the data set?
Okay. So basically, yeah, anybody else?
Outliers are values that occur random, right? Meaning they do not occur as a central tendency, but they are something that happens one odd time, right?
Yeah,
So there are
basically,
few odd times.
yeah, we can
Out of
simply
the
say,
range.
out of range kind of. So we can basically say this outlier or extreme value, something like that differ. Basically, they are different. Differ from the normal observation. From the most other observations. Yes or no? Right?
Yes, sir. So, but can
Yes,
we
sir.
also
Sir,
say no, that it can create heavy impact on the average of
Yeah,
the
yeah,
number?
yeah. That is something we are going to yesterday. Thing is that this is something called outlier. Okay, let me take that example. Suppose I'm going to say, yeah, sorry, yeah. So I took the example of 1, 2, 3, right? I think I had 1, 3, 3, 4, 5. For example. So 1, 3, 3, 4, 5. Correct? What was the mean for this data set? 3.2. Median was 3, right? And mod was also 3. Yes or no? Now, tell me, suppose there is an extreme value in this observation. That is, let's say, instead of, for example, instead of 5, I'm assuming, let's say you have some 500. Just assume, okay? And it is something as compared to other observations, this is something I can consider as an extreme value, yes or no?
yes, sir. It is different from the other values, so
Right?
we can
We can
assume.
consider, right? Basically. Now, what
Yeah.
will be the mean of this data set? Can you compute? Anyone? Just tell me. Okay, basically it will be 1 plus 3, 4, 3, 7, 4, 11. So basically 511 divided by 5. Okay, anyone can calculate the value? 511 divided by 5. So it will be 515 not 1 not 2.2, right? Yes or no?
1.2, sir.
Yes, sir.
Yeah, what is the median? Median is 3. Mod is also 3, right?
Yeah.
Yeah.
So if you see, if you observe carefully, so this mean and this mean, correct?
Yeah.
Median, mod. So can I say here, median and mod is least affected by the outliers as compared to mean?
Mean, yes.
Correct. If you see mean is heavily affected, right? See, there is a significant difference in mean due to extreme values as compared to median and mod. Right? For this particular example, median is not changed, mod is also not changed, but we can't say it is not affected at lot. At all. But yeah, median and mod is least affected, but while mean is there is a significant effect on mean. Is this clear?
Yes, sir.
Yes, sir. Clear.
Sir, can you please explain once again?
Okay, so if you see, this was the observations, right? So I had mean, this is 3.2, median was 3, mod was 3. Yes or no?
Yes, sir.
Correct. Due to one extreme value, which is 500, what was the mean? If you see, if you will calculate the mean I got 1 not 2.2, right? And median is still 3 for this data set, and mod is still 3 for this data set, right? So if you see, there is a significant difference in the mean value as compared to median and mod. Okay, so we can say median and mod is least affected by the outliers in the data, while mean is there is a significant difference in the mean value for the due to outliers. Okay.
Yes, sir.
Clear? Yeah. So I think so. This is something we have done for measures of central tendency. Next one is measures of dispersion. Okay. Okay, anyone can tell me why we are moving to this dispersion, or why we are interested to know this thing?
Because the measures of dispersion can tell us more about the data set, and measures of center tendency only were only telling us about the median average value, and
I
measure
mean,
of dispersion
okay, what do you mean by
Sir,
more
sir,
about your
sir,
data set?
sir, can you?
for
Hello.
we can have an idea of every not every but many of the attributes of the data set.
Sir,
Okay,
hello, hello.
like,
Sir,
yeah, go ahead.
sir, can I say something?
Yeah, please go ahead.
Sir, sir, it helps to understanding how much data is, matlab, data is spread,
Spread.
its variations, how much, like,
Okay, okay.
yeah, sir.
I mean, how much spreadness, or how my data set is this, I
How
mean,
much
what
its
kind?
various, yes.
Okay, so variability from where?
Sir, what, sir?
Variability, see, you're going to check variability, but from where you're going to check variability? I mean, there should be some unit or something, right? Okay,
No
no
idea,
problem.
sir.
No problem. No problem. I mean, okay, no problem. So first measure of dispersion is called range. Okay, which is very simple. Range has been defined as nothing but maximum minus minimum, right? So if you
Yes.
see the range for this data set, what is the range? Okay, before that, what is the range? Range is 4, correct? If you see for this data set, so range is 499,
400.
right? So I can simply say range is sensitive to outliers, right? Why it's sensitive to outliers? Because it's consider only max and minimum. I mean, maximum observation and minimum observation my data of my data set, right? And extreme values are will occur. I mean, this maximum case and minimum case. Yes or no?
But sir, let me give another example, right?
Okay.
Say for instance, my range is starting from 1 and going up till 100, and
Okay.
then it starts again from 10,000 and goes to 100,000, right? So in that case, my range and my outlier would be something like 500, right? Or 5,000, which is somewhere in the middle, right? But if I take that as an example, because I have 10 set of records from 1 to 10, and then I have, say for instance, 10,001 to 10,010. So 10, 10 balanced, right?
Okay.
And
First of
in
all,
between, I have got 5,000.
okay, you are saying 1 to 100 first, sir.
1 to 10. 1 to 10 I have.
Okay, 1 to 10. Okay.
Then I have, then the other part of the same data set is set 1,000 to 1,010.
Okay, means 1,000 to 10,000. So
No,
this is the
1,000 to 1,010. 1,000 to 1,010. 1,001,
okay.
1,002,
Okay.
1,003, 1,010. Okay.
Okay.
Now my outlier would be somewhere in between, which is like a 500, right? Would it not be an outlier? Because
first of all, first of all, let me tell you to check the whether that is the outlier or not, right? So see, first of all, we can't judge any observation randomly, which is outliers. Okay. To check the outlier, there is one method. So you have to check. I mean, if there is any observation from your data set, okay, which is if less than, which is q. This is the one of the method. We are not going to
right.
from where
We
you
have not
check.
yet covered, right?
Okay.
Interquartile range.
Correct. If this is the case, or if there is any observations which is more than this case, that I will consider as outlier. We can't judge any value randomly outlier, right?
Okay. So even if my data is spread in 2 centers, but one value in between cannot be an outlier, because if it does not fit this criteria, that's what you're saying.
We have to cross check actually. We have to cross check.
Okay, got it. Thank you.
If yeah, okay. So basically, here point is if range is something, so range is sensitive to outliers. Okay, because something, see, outliers sometimes, if you see, it differs from normal observation. Okay, Normal observation, suppose you have observations like this, like this, like this. Okay. Outlier is this, for example. So this is the maximum one, correct? Something like that. Okay. So this is the range, but we are going to move to yesterday about another measures of dispersion, which is called the second one, is called the variance. So why we are moving to the variance part basically? Range, if you see, range is going to cover only two values, right? Which it covers only maximum and minimum. Yes or no? But what about others? Why we are moving to the variance and all? Okay. So to know the variability of my data set, first of all, why we are moving to the variability part? Okay, suppose I took in the beginning of the session, I took one example called that university A and university B. Okay, there were packages of some 5 students in both. Okay, 30, 30, 30, 30. Now, can you tell me? So, what was the average? Average package was 30 lakh for this, and average is also 30 for this case, correct? Yes or no? Yeah, see, average is 30, right, for both cases.
Yes, sir.
Correct?
Yes, sir.
Now, if I will say a annual average package in both university is same, only based on this case. So, in reality, is this true? Will it be?
No,
Can
sir.
I say both are the
No,
equally likely?
sir.
No.
Why?
Sir, because the total average of sir average is the same.
Average is same, but can I say
Av-
both university is
no,
the same? Performance of both university
no,
is
sir.
same?
No.
Why?
Sir, because the both average are same.
Average are same, but why can't say performance is the same?
Each data points are different, sir.
Correct? So if you see, there is variability in the observations, yes or no?
Yes,
For
sir.
this case, right? It's not like in the both cases it's a 30, 30, 30, 30, right? Yes, no? Are you getting why we are moving to the variance? If you see in this case, mean is the same, but if you see the actual observations of your data set, it's a varying, right? There is a variability, correct? So to
Yes, sir.
know the variability of your data set, so there is one formula called so there are basically two formula, which is called the population variance and sample variance. So both are the little bit different. I will tell you. Okay, this is the sample way what. So in population variance, so we are going to consider all the observations of your data set. It's a 1 by n summation of I is equal to n xi minus x bar square. So this is, we are going to see the deviation of each observation from its mean. And what's the difference? This is notation for sigma square. And what's the difference with sample variance, which is nothing but 1 upon n minus 1 summation I is equal to 1 to n xi minus x bar square, and notation for this is s square, small s square. Okay, so the reason behind we are using, why we are using n and n minus 1, these things we are not going to study in this stats 1 foundational course. You will be study, I mean, you will know the reason behind this in stats 2 course and all. There is something degree of freedom and all, then unbiased condition and all. Okay, so we are not going to that. As of now, you can keep in your mind. So population variance is 1 by n summation xi minus x bar square, and 1 upon n minus 1 summation of I is equal to 1 to n xi minus x bar whole square. So if you see, we are checking the deviation of each observation from its mean, right? So by saying this, there will be some deviation, right? For this case, right? For the very first case, right? I mean, so what are the each xi? You have 10, 20, 30, 40, and 50. And what is the x bar? X bar we got as a 30, right? So if you see by the formula, what we have to calculate? Xi minus x bar, correct? Yes or no? So to calculate the variance, so this is the approach, xi minus x bar. So 10 minus 30, right? This 10 minus this 30. I will get minus 20, 20 minus 30, minus 10, 30 minus 30, 0, 40 minus 30, 10, 50 minus 30, 20. What is the next? I have to do xi minus x bar square. So it will be 400, 100, 0, 100, and 400, right? If you see what is the next, we have to do the addition of all these observations. So addition of all these observations will be 1000, correct? Now in the question, it will be clearly mentioned whether you have to calculate the population variance or sample variance. If it is mentioned population variance, then you have to divide by 1 by 5, because I have some 5 observations, right? 1 upon n. It will be 1 upon 5 and into 1000, right? If its question is about sample variance, then you have to calculate 1 upon n minus 1. So 5 minus 1 will be 4 into 1000. So is this clear? Computation part is okay for everyone?
Yes.
Yes, sir.
Is this clear? Yeah. Okay.
Yes, sir.
So yeah, so there is one relationship between this population variance and sample variance. You can keep in. Okay, I will tell you what's the importance of that. Okay, what is this sigma square population variance? So 1 by n summation of I is equal to 1 to n xi minus x bar square, right? And what is the sample variance? S square as 1 upon n minus 1 summation of I is equal to 1 to n xi minus x bar square. Yes or no? Right? Now, tell me, I can write this as a n times of sigma square equal to summation of I is equal to 1 to n xi minus x bar whole square. Yes or no? And this one I can write on the right hand side, I can write n minus 1 times s square as summation of I is equal to n xi minus x bar square. Any doubt till now?
No, sir.
If you see, right hand side is equal, right?
Yes, sir.
Yes, sir.
So can I say from here n times of sigma square is same as n minus 1 times s square or not?
Sir, we can say.
I
Yes,
can
sir.
say, right? So
Yes,
this
sir.
is something you can keep in your mind. While because suppose I have asked if the for a data set population variance is given to you, sample variance is given to you, and I ask what is the number of observation for that data set. Then sigma square is given to you, s square is given to you. You can simply calculate the value of n. Yes or
sir.
no? Or n is given to you, sigma square is given to you, and I ask what will the sample variance. You can simply, I mean, out of these 3 quantities, if any 2 quantities given to you, you can simply calculate the other unknown one. Correct?
Yes.
Yes, sir.
Yes, sir.
Fine. Yeah. Now, tell me, in the case of mean, median, and all, we have seen that addition of a constant multiplied by a constant, there was effect, right? What about variance? Okay, whether there will be effect or not. Okay, so if suppose I have observations x1, x2 up to xn, this is the old data set. Okay, now I want to see if I will add a constant c, then what will be the new data set. So let's say new data set, I'm going to represent as yi as a xi plus c. Okay, is this all right? So this yi represents the observations of new data set. Okay, now I wanted to see whether what will be the effect of adding a constant. Okay, so I'm going to take the population variance. We can do same for the sample variance as well. Okay, tell me. So sigma y square will be so sigma square will be y square will be 1 upon n summation of I is equal to 1 to n yi minus y bar square. Yes or no?
Yes, sir.
So
Yes, sir.
this sigma square y square is nothing but I'm going to check what will be the effect for new data set. Okay, if you see yi, okay, what will the y bar from here? If you add a constant to all the observations, this y bar will be, tell me.
yi plus
X bar plus C.
X bar plus C, right? So this y bar is mean of my new data set, old mean plus C. Yes or no? Right?
Yes, sir.
So if you see 1 upon n, summation of I is equal to n. So yi is nothing but xi plus c minus y bar is x bar plus c whole square. Correct? If you see 1 upon n, summation I is equal to n, xi plus c minus x bar minus c. Can I do?
So,
Yes.
So if you see c will get cancelled out. I got 1 upon n, summation I is equal to 1 to n, xi minus x bar whole square. Correct? What is this?
yes, sir.
This is nothing but variance of the
Previous
old
data
data
set.
set. Correct?
Yes.
So what we have observed from here, if we are going to add a constant c, right? So there will not be any effect on value, I mean on the variance, right? So new variance, I mean variance of new data set will be variance of old data set. Is this clear? While we are going to add a constant, is this clear?
Yes,
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 sir.
sir.
But
Correct.
sir, I have a question on this one, and I asked this earlier as well.
Hmm.
So the question is,
Hmm.
if you change one value,
Hmm.
one x value, right? Then
But
the mean is impacted
then it
and
will
my
impact.
variance is impacted, but I don't know how it is impacted.
No, for
Right?
one, then you have to do manually then, I think. Because see, one means this is the case when you have to add a constant to all the observations. It's not about only one observation. Okay. So this
No,
property
but the
you
question says, but
see,
I in the graded assignment for this week, right? We have a question wherein the mean is given, the standard variance is given, and they are asking that there was one value that was changed.
that is
And I
another
don't
thing.
know.
It's that is another thing. Okay, I think I got the idea whether you are talking about. You're talking about question number 2 and 3, right?
Yeah,
Okay, it's not about where you have to add observations to add a constant to all the observations.
it only impacts one. Na?
Sorry.
It only impacts one value.
See, it's a see that property. Okay, let me give you a hint. That property is, will be helpful for this question number 4 if you read the question number 4 carefully. If you see the question number question number 4, it's about 1
1
rupee
rupee is
is
added to all
to
of them.
all
Yeah,
the
yes,
readers.
exactly.
Okay.
This is covered in the course as well, and I got the idea, right?
Hmm.
But this one, the other two questions, they change only one variable, right?
See,
So
okay,
my mean is impacted. I can somehow calculate mean by doing some arithmetic here and there,
yes,
right?
yes.
But my variance is a square of some difference, right? So I don't know how to calculate that.
No. Okay, don't worry. I got your point. I will explain that one. No worries. Okay, just give me a minute. Okay.
Okay.
Okay, yeah. Just give me a minute. I got your point where you are liking that. Okay, just give me a minute. You will get the idea how to do that one. Okay.
Perfect.
Let me just
Thank you.
cover this where we have to multiply by constant. Okay. If I want to multiply by a constant, okay. Let's say multiply by constant c. So my new observation will be xi times c. Okay. And mean will be x bar times c. Yes or no by the property.
Yes, sir.
Okay.
Yes.
Now, so if you see what is the sigma y square? 1 upon n summation I is equal to 1 to n yi minus y bar square, right? So 1 upon n summation I is equal to 1 to n, okay, xi into c minus x bar into c whole square. Yes or no? See, this is the new observation.
Yes.
This is the new mean,
Yes.
right? So
Yes.
c I can take outside from here. I can take common. So it will be, since it's a square, so c square will be common, right?
Right.
Any doubt till now? So this is c square outside of this I. So I can take c square from here. So it will be 1 upon n summation I is equal to 1 to n xi minus x bar square. Yes or no? What is this quantity? This is nothing but sigma x square, right? Yes or no? So if you see what
Yes,
we
sir.
have observed, so this is nothing but new variance is equal to c square times old variance. Yes. Any doubt? So whenever you have to multiply it by a constant to all the observation, then your new variance will be square times, I mean old variance into square of that particular constant. Okay. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Now come to that point. I think who has asked that's the mean median?
I, sir.
Yeah,
Kazim.
Abdul, right? Okay, fine. So I'm going to give you with the help. Suppose this is the sigma square. So 1 upon n summation I is equal to 1 to n xi minus x bar square, right? This is the formula for population variance, right?
Yes.
Now tell me 1 upon n summation I is equal to 1 to n. Can I expand this thing? So I will get xi square plus x bar square minus 2 times of xi into x bar. Yes
Yeah.
or no?
2AB. Yeah.
Yeah, 2AB, right? So
Yeah.
this is the actually formula of expansion of a minus b whole square, right? Now, if you will take summation inside the bracket, I will get summation of I is equal to 1 to n xi square plus summation of I is equal to 1 to n x bar square minus 2 times of x bar I can take outside, then summation of I is equal to 1 to n xi. So far, so good. Right? Now, tell me, x bar is what? X bar is nothing but 1 upon n summation of xi. Correct? X bar is something defined like this, right?
Yes, the mean. The
Now,
mean.
the mean
Okay.
case, right? So can I write n times of x bar as a summation of xi? Yes or no?
Yes.
So
Yes.
this summation of xi, can I replace with n times of x bar or not?
Surely.
Abdul, is it clear?
Yes.
Right?
Yes.
So what will be the next step? It will be 1 upon n summation of I is equal to 1 to n xi square. Now tell me, what about this terminology? This is something we are adding x bar square n times, right?
Right.
So I will get n times of x bar square.
Right.
So I got n times of x bar square minus 2x bar, and this is something n times of x bar. Correct? Now it will be 1 upon n summation of I is equal to 1 to n xi square plus nx bar square minus 2nx bar square.
Minus 2nx bar square.
This x bar into x bar. Correct?
Right. Right.
Correct?
Okay.
Now, so what we got, 1 upon n summation of I is equal to 1 to n xi square minus n times of x bar square. See,
Yes.
this is
Yes. Yes.
a minus 2a.
Yes.
Right?
Yeah.
Correct?
Yeah.
So we got sigma square as 1 upon n summation of xi square, this will be for I, minus, and this will get, I mean, basically it will be n x bar square divided by n, so it will get cancel out. So sigma square we got 1 upon n summation of xi square minus x bar square.
The mean, the square of the mean. Okay.
Square of the mean, right? Now from where you can calculate.
Variance
Okay.
equals to
So this
1
is
by
the expansion form of, I mean, another form of the, I mean, similarly you can do for the sample variance also, right? So you can keep in your mind this one or this one, anything. This one is the helpful because if you are going to calculate for sample variance, so it will be n minus 1 basically. Okay. So now you can simply do, if you found for the mean, right? You can do the mean square, correct? You can now you can find the square of the, I mean, summation of the square of the observations. Yes or no? Correct. From where?
Whatever is the current.
See,
Because I
okay,
only
let me,
have the standard
one
variance, I
second.
would have
Let
to.
me give you one hint. Let me give you. First of all, this thing, from this equation, I can find the summation of xi square or not?
Summation of xi square I can
find, right? Because
Yes.
I will be
Yes.
having mean, I have number of observation, I can find summation of xi square, right? So this
Summation
will
of
be
xi
for
square,
your,
yeah.
this will be for your older one.
Old one. This
then
would be,
you
I would calculate for the old, and then
Then-
I would know what xi square is, and then I would subtract
Correct,
the
correct.
difference, and then I would do that.
whatever, it's due date is still there. So
Right,
this is
right,
something, this is a
right.
hint I can
Got
give you. Okay, got it?
Okay.
Okay. Yeah.
Okay, thank you.
Yeah.
Thank you.
All right. Yeah. Okay, so just give me 1 minute. I will be back. Okay, in 1 minute, then we
Yeah.
can start.
Can I
Yeah?
take a screen print of this one?
No problem, no problem. If you want, if you're okay with it, I can share the slides also.
Yes, please. Please, that would be
Will
good.
you able to understand after this session, because this is something.
Yeah.
Share, sir.
Yes, sir. Please share.
Okay. Then I will ask to the team. They will upload on the portal. Okay.
Okay. Thank you.
Yeah. You can take the screenshot as of now. No.
Okay.
I don't, okay.
Thank you.
Yeah.
So screenshot, it becomes cluttered. So many screenshot. Please.
No. As of for this
upload it on
particular, you can take, for this particular thing you can take. I will upload the PDF under the supplementary content you will get. Okay.
Sir, you can paste in chat also.
Okay. After this session, I will paste.
Okay, sir.
Sir, excuse me, sir. Hello.
Sir has
will be
stepped away
back
for some time. Sorry, repeating, sir has stepped away for some time. So, maybe
Hello, am I audible?
Yes, sir.
Yes, sir.
Fine. Okay, so far we have seen variance, population variant and sample variance, right? So next topic is about standard deviation. Okay, so population variance is 1 upon n summation xi minus x bar square, and sample variance is 1 upon n minus 1 summation of xi minus x bar square. So another topic is standard deviation. Okay, any one of you can tell me what is that? Standard deviation, those who have watched the lectures, yeah, just feel free to say whatever the things you got, you have understood. You can simply tell us, no problem.
We'll just under root of the standard variation.
Square root of the
Because
variance.
standard variation.
No, okay, problem. Sorry, not a problem.
Variance.
Correct. Okay, now, so the same thing I can calculate for the population standard. So population standard deviation will be sigma, which is square root of sigma. So it will be square root of 1 upon n summation of xi minus x bar square, and
Sir,
s
can
will
you
be,
tell the physical meanings, sir?
yeah, 1 minute, 1 minute. So 1 upon n minus 1 summation of xi minus x bar square.
There is
Now,
also some concept of unit.
any one of you can tell me why we are, if I have calculated already, I know the variance of my data set, then what's the need of taking the square root, or what's the need of calculating standard deviation?
for returning the result back into the same units as the data was.
Correct, correct. Yeah, so it will be easier to compare the data set. Basically, for example, suppose I have data set of age, for example, okay, then you will get the okay, mean you will get in something, let's say 43 year, for, I mean, for a random data set. We don't have data, I'm just doing the for a dummy data set. Okay, then for the what will the variance, it will be, let's say it's something, some 10 year square, right? It will be year square, because in variance we are doing xi minus x bar square. Yes or no? Correct.
Yes, sir.
If you see your original data was in year, your variance is in year square. So it's so good to take the square root, so that you will get square root of 10 year. Okay. So your unit will be the same as the same unit as your original data set. Yes or no? Okay.
Yes, sir.
So this is the helpful to compare our data. Now, we have seen if I will add a constant, then my new variance will be same as old variance, right? Correct. If I'm going to add a constant, correct, there will not be effect of adding a constant. Correct. This is something we have seen. So similar concept will apply for standard deviation. There will not, because this is just a square root. So I can simply say new standard deviation is same as the old standard deviation. Yes or no? While we are going to add a constant. Yes, no, any doubt? Correct. If you see, also we have seen, if we are going to multiply by a constant, c, then what we got? For in case of variance, we got new variance. This is same as c square times old variance. Correct. What about standard deviation? If I have, we know standard deviation is nothing but square root of this. So new standard deviation will be Square root of this case will be C times old standard deviation. Is this clear?
Yes, sir.
Right? Any doubt?
No, sir.
Yes, no. It's
No,
fine,
sir.
right? Okay.
Yes.
Yeah. Okay, great. Okay, so next concept is, I think it's the percentile. Okay. So,
Yes.
okay. How many of you covered till percentile? I think percentile is the last lecture, right? If I'm not wrong.
Yes,
Yes,
it's
sir.
a last concept.
Yes.
Yes, sir.
So what do you mean by percentiles? Anyone?
Percentile tells us the number of people we are ahead of or number of people are behind us.
Comparative analysis.
Okay. So let me tell you the meaning of percentage. Suppose basically if you by the name, it's something percentage terminology is there, right? So it divides the data. Okay, suppose I'm saying 20, let's say 30th percentile. Okay. Okay, for example. So what do you
Yeah.
mean by how will you interpret the meaning of this 30th percentile?
So we can say that 70% of the people are ahead of us, and I am ahead of the 30% of the people.
Correct.
My
Basically,
position is 30th.
it's a meaning simply means 30% of the observations are below this, and remaining 70% of the observations will be above this, right? If I will say 40th percentile, that means 40% of the observations will be below this, and remaining 60% observations will be above this. Okay, I think have you appeared for JEE exam or something like that? Any one of you know what is the JEE? Correct. In JEE
Yes, sir.
something you are getting percentile, right? Not a percentage or something, right?
Yes, sir.
Suppose you got 90th percentile. What does this mean? Yeah, anyone? Yeah, feel free to say.
That
It's
means
Haven't.
this person has performed better than 90% of the population, and
correct.
10% population is ahead of.
Ahead of. Basically, I can say, I can simply say 90% of the people are below this, and 10% people are above this. So that is the simple interpretation or meaning of the percentile. Is this clear? Any doubt?
No doubt.
No. Oh, fine. So let me move to the how we can compute the things manually. So while computing the percentile, so there are some steps. Okay. So first step is we have to arrange the data in increasing order. Okay. Give me one. Okay. So first step is we have to arrange the data set in increasing order, or you can say ascending order. So there is two things we have to observe. First one is what is the N and what is the P. Okay. N is number of observation, P is the which percentile you have to calculate. So second step is if we have to calculate the value of N into P. So this N into P may be integer, may not be integer, right? What if it's not an integer? I mean, value of these two is not an integer. If value of these two is not an integer, then we have to take the smallest integer greater than this value. Okay. Then we have to take. Okay. If you are not able to understand, don't worry. I will take one to two example. You will get the idea. We have to take smallest integer. Okay, greater than NP. Okay, greater than this N into P. Okay, and the data in that position will be the percentile. I mean, in this position, this smallest integer greater than p. So data in that position, okay, the data in that position will be my required percentile. Now, another case is that value of n into p may be integer, right? If it's an integer, okay, then average of the values, okay, we have to take the average of the values, okay, which values in the positions np and np plus 1 in these two positions. Now let me take some example. For example, I have data set, let's say 11, okay, then 10, then let's say I have 9, let's say I have 13, 12, 15. Okay, so this is the observation. Let's say, let me take one more, let's say 70. Okay, so what is the first step, very first step?
Arrange in ascending order.
Arrange in ascending order, right? First of all, we have to arrange. So what is the arrangement? It will be 9, 10, 11, 12, 13, 15 and 17. Correct? Now tell me, what is the n? N is 7, right?
Yes.
Now if I ask, tell me what is the let's say 40th percentile of this data set. Okay. So what we have to do? See, what is the 40th percentile? So that means p will be 40%. That means 0.4, right?
Yes.
So
0.4
let's
into
say
7.
we have to calculate the n into p, right? So what is the n? N is 7, p is 0.4. So what is the value of this multiplication? This is 2.8.
8.
Tell
And
me this,
percentile will be
if you see, we had two cases. This np can be integer, and I mean, it is there is two cases. When it's not an integer, when it's an integer. So this is in decimal point, right?
Yes.
So
So
what we
it
have to
will
do?
be
We have to
third.
take the smallest integer, which is a greater than. Smallest integer means, see, after 2.1, there are some greater integer are 3, 4, 5, anything, right? So we have to we have
Yes,
to
sir.
take
3.
smallest integer, which is greater than this. So what is this? 3,
3.
right? So this 3 is not 40%. So value at the third position
Third observation.
will be my 40th%. What is
40th
this? This is
percentile.
11. So
11.
11 is the 40th percentile of my data. Is this clear?
Yes, sir.
Okay. Let's say when we'll get no, I mean, when I will get integer value in case of 7.
Let's increase one observation.
Yeah, let's increase one observation. Okay. Okay, this is clear. Okay, let me take another one. Let's say I'm saying what is
Sir,
the 80th percentile of this data set. Okay. So what will be my, if you see, n is 7. So 80th percentile means p will be 80 by 100. That means 0.8, right? So value of
Yes.
np will be 7 into 0.8, which is nothing but 5.
5.6.
So that means what is the next smallest integer? That is the 6th,
6.
right?
Yes.
6. So 6th observation is 15,
15.
right? So 15 is the 80th percentile of my this data set, right?
Yes, sir.
Okay.
sir,
Now
what if it is 5.5 like that? How to round off then?
anything if it's in decimal, even though if it's 5.1, right? If it's in
So
decimal, we have to
5.5.
see if it's still 5.5. So listen me carefully what I'm saying. If it's in decimal, we have to take the next smallest integer, which is greater than this. Okay, clear? Okay, fine. So suppose I have observations. Let's say in this observation, I have been added one more observation, which is 18. So I will be having data 9, 10, 11, 12, 13, 15, 17, and 18 for me. So here n is 8, right? Correct? If I will ask, what is the, let's say, 50th percentile of my data set. So P will be 0.5, right? So what will be value of
Yes, sir.
NP?
4.
8
Is
into
4.
0.5, which is 4. Now,
4,
if you
4.
see, this is an integer, right? If
Yes.
value of NP is an integer, we have to take the average of the values in the position NP and NP plus 1th, right? So what is the observation at 4th place? Basically, we have to take the average of 4th observation and 5th observation, right? So what
Okay.
is the 4th observation? So 12, and what is the 5th, which is 13. So it average of these two will be 12.5. So this is the 50th percentile of my data set. Is this clear? Okay.
Yes,
So
sir.
Yes,
basically,
sir.
50th percentile nothing but median of your data set. Okay. Because median, what does median do? Median is nothing but median divides the data into two equal parts. 50th percentile means 50% of the observation will be below this and 50% of the observation will be above that value, right? So anyway, it divides the data in two equal parts, right?
Yes, sir.
Clear? So is this clear? It's okay for everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Any doubt?
No, sir.
No, sir.
Okay, great. Okay, then do you have pen and paper right now?
Yes, sir.
Yes, sir.
So just tell me what will be the 70th percentile of this data set, okay, and 20th percentile of this data set. Just tell me, just to check whether you got the idea or not. You can take okay, so some 2 to 3 minutes.
Twentieth is 15, sir.
Yes, sir. 70 is 15.
70th is
Yes, sir.
15.
And
Yes, sir.
20
Yes, sir.
is 10. It's 10.
20th is 10. Okay. So
Yes,
basically
sir.
N is 8,
Yes, sir.
right? Okay.
Yes, sir.
So
8 times
P
0.7.
for 70th, if P will be 0.7, so 8 into 0.7, which is 5.6. So
6.
So 6th is 15, correct? That's right. And 20th, so 8 into 0.2, which is 1 point, that is second, that is 10. Yeah, correct. Great.
Yes,
Okay,
sir.
so let's move to the next part, that is called the quartiles. Okay. So by the name, quartiles means basically, so it divides the data into one. So what is the quarter? Quarter is 1/4 of your data set, right? So it divides the data in 4 equal parts. Okay, here just assume this all are equal. Okay, just it should all be equal. Okay, equal means 4 equal parts means this should cover the 25%. This should be 25%. This should be 25%. This should be 25%. Right. This is something quartiles mean. It divides my data set into 4 equal parts. Okay. So if you see, this is called first quartile, which is we are normally denoting with Q1, and this one with Q2, second quartile, and this one is Q3, is the third quartile. So by this, can you tell me what is the Q1 here from here?
25%.
So it's a 25th percentile, right? Yes or no? Q2, I
Yes,
can
sir.
simply say it's a 50th percentile,
Yes.
right? And Q3 is nothing but 75th
75.
percentile,
75.
correct? So by using the concept of percentile and all, I can simply calculate the Q1 or not? Q1, Q2, Q3?
Yes, sir.
Yes, sir.
So tell me, for the above observation 9, 10, 11, and what was that? See, be careful what people normally make mistake. They are not arranging the data set into ascending order. Okay. So very first step is we have to arrange the data set in ascending order. Okay. Tell me what will the Q1 you will calculate me.
Q1.
See, yeah, see, just tell me, I will write. N is
7.
P will be
P is 20.
0.25.
0.25.
Points, sir.
Next step is what?
7 into 0.25.
So
NP.
NP, right? So it will be
1.7.
7 into 0.25. What is the value
Sir,
for this?
it's 10.
1.75. So it would be converted to 2.
Correct. So we have to take the second observation, right? So second observation is
Yeah.
10, right?
10.
So from here I got Q1 as 10, right? What about Q2?
7 into 0.5.
12. Q2 is
12.
median. Median is 12.
12.
It's
That means
12.
fourth observation, right? So fourth observation is 12. So Q2 I got 12, right?
Yes,
Very
sir.
good. What about Q3? So
15.
N into P,
20 into 0.75.
correct? So that means which is
Sir, if odd number of observations are there, we can take the 50th percentage as middle
directly.
observation.
Yeah, that's why I told, right? 50th percentile is nothing but the median by the definition. Okay.
Even if it is even, we can add the middle two terms and then divide by 2.
Correct,
And
correct. That is the definition of median, right? Okay. So 5.2, that is sixth observation. So sixth observation is 15, right?
Yeah.
Am I right? So Q3
Yes.
is 15, correct?
Yes.
So we got Q1 as 10, correct? Q2 as 12, Q3 is 15. So there is one concept called 5-number summary. Okay. Hope you have seen. What is that 5-number summary? So 5-number summary of any data set just covers the minimum, okay, Q1, Q2, Q3 and maximum value. Okay, this is something 5-number summary. And another concept called the IQR. What is the IQR? IQR is nothing but interpreted as interquartile range. Okay, what is this IQR? IQR is defined in nothing but 1 minute Q3 minus Q1. So what is the Q1, Q3 for this data set is 15 and Q1 is 10. So we can simply say IQR, interquartile range of my data set, is 5. Is this clear?
Yes, sir.
Okay.
Yes, sir.
Now another, yeah.
So
Someone
what does the
yeah.
5-number summary mean?
Yeah, it's just a nomenclature. If you have given the minimum value, what is the Q1, Q2, Q3 and maximum? Suppose you have represented these 5 things, right? These 5 things. I mean, you have summarized your data set by these 5 numbers. It's called 5-number summary. I mean, minimum is this, first quartile is this, means 25% observations are below this something. Q2 is this.
Okay, so
Q3
minimum
is this.
is minimum the first term and Q1 is 25 and 50%
Correct.
respectively.
Correct.
Okay.
So you can
And
simply say
what is
these are the, I mean, see, you can simply summarize your data set with this 5 numbers. Okay.
Okay.
What is the use of IQR, sir?
IQR is a different thing. Yeah, go ahead.
So is box plot and 5-number summary same thing?
Yes, you can plot the box plot with the help of 5-number summary actually.
Okay, sir.
Okay. Okay.
Yes, sir.
So there is this concept called IQR is
So
clear
could
to
you
IQR.
explain how?
Which one?
Oh,
Yeah, sorry.
box plot.
Yeah, I will come to that
The
point.
box plot.
Yeah, one second.
Okay.
So basically, this 5-number summary is basically set of this descriptive statistic. I mean, this descriptive statistic means, see, in descriptive statistic, what we have done, we studied like we are going to describe, we are going to summarize, or we are going to give some description about my data set, right? If we are going to give description or some summary of my data set by this 5 number, so basically this is called the 5-number summary. Okay. Now, another concept, this IQR is clear. This is nothing but Q3 minus Q1. Okay.
Yes, sir. Okay.
Okay. Now,
understood.
What is the box plot actually? Box plot is nothing but you can simply say it's like you can draw with this help of this 5-number summary. Okay.
So
how
what's
you
the
can do?
use of IQR, sir?
Okay, so just think and tell me. Q1 we have calculated Q1 and what Q1 tells you?
Quarter percent, the percentage of 25% of the data.
Okay, and what Q3?
75 percentile.
Okay, how will you interpret that, means?
Like what means data regarding
What do you
that
mean by yeah?
data? How many like what is the
Yeah, just think. No problem. You take your time.
the range, sir? Range.
So basically, see, IQR is nothing but difference between Q3 minus Q1.
Sir.
Okay, right? Yes or no? So basically, when you will plot your see, it's basically gives you measure of variability. I mean, it's basically measures of variability. One of the measure of variability. Okay. So if you see, so this is okay. If you plot a box plot, right? So this box plot is represented like this. You can do in horizontal manner also. So this represents the Q1 and this represents the Q3, and Q2 will be somewhere not exactly in the middle. It can vary up or down as per the data set. Okay. So this gives you difference between Q3 minus Q1. Okay. Basically, this is the minimum value. This is the maximum value. Okay. So Q3 minus Q1 is the IQR. This is something we have defined. Defined this IQR, right?
Yes, sir.
Correct. So whenever you have quartiles and all, right, so you will be able to know how much variability is there.
Okay, sir.
Variability in your data set, right? Basically, if you see IQR, basically it's very useful to detect my outliers and remove my outliers from my data set.
Okay, sir. Okay, sir.
How will you help you? See, whenever you will study about some, economics or finance related things, right? So this is very helpful to in that case. Okay. Why outlier? Because I will tell you the maximum. I mean, any observation is there. Suppose this is case, right? You have plotted box plot and you got one observation. So this and below this is something called this one and this one as the outliers actually.
Yes, sir.
Okay. So basically it will help you. Why? Basically outliers is what? If you see outliers of any something, I can identify if this is less than Q1 minus 1.5 times of IQR. We are not going to behind the derivation. I mean, what is the from where this 1.5 came and all. As of now, we are just going to see the procedure. We'll discuss it later also, right? Now, if there is any observation less than Q1 minus 1.5 times of IQR, I will consider as outlier. If there is any observation which is greater than Q3 plus 1.5 times of IQR, then that will be considered as outlier. So it's helpful to know the outliers, to identify the outliers, to detect the outliers and remove the outliers from your data set. As per the, I mean, it depends on what decision you are going to take for the outliers in your data set. But this is the helpful in this case and all. Okay.
Okay, sir.
Got it basically.
Thank you, sir. Okay.
Yeah. So this is something I can calculate whether outliers is there in my data set or not. Okay. So tell me for this data set, Q1 was 10, right? Correct. Let me write down. Q1 was 10 and Q2 was 12. I think Q3 was how much?
15, sir.
15, right? Yeah.
Yes, sir.
So what is the IQR? IQR is Q3 minus Q1, which is 5.
5.
Right.
5.
So we have to observe. So what is this quantity? First compute this quantity. So Q1 means 10 minus 1.5 times of 5, right? So what you will get?
7.5.
Yeah, I mean, see, 1.5
2.5.
that is
2.5.
2.5.
right? This is 2.5. And next is Q3 plus 1.5. So what is Q3? 15 plus 1.5 into 5, right? Which is
17.5.
22.5.
Yeah, 22.5.
22.5, sir.
Yeah, 22.5. So
Yeah.
we have to see, is there any observation which is less than this quantity in your data set?
No, sir.
So our observation was 9, 10, 11 and 12, 13, 15, 17, right?
Yes,
Correct?
sir.
So is there any observation which is less than this quantity?
No, sir.
No. Is there any observation which is greater than this quantity?
No.
No,
That means there is no outlier in this my data set. Is this clear?
Yes, sir.
Correct?
Yes, sir.
Fine? Okay. All right.
Yes, sir.
Okay.
Yeah.
So this is something you can do the things, right?
Is 1.5 constant?
Yeah, it's a constant value. It's a constant value. Okay. We are not going to that in derivation of the formula and all. As of this foundational level course, just keep the formula in your mind. That's okay. We are not going in that depth. Okay. Fine. Okay, I think I have covered all the content of this week 3, right?
Yes, yes, sir.
Is
Sir,
there any
please
doubt?
do post that document.
Okay, one second. Let me try to copy paste here in the chat if it's possible.
Yes, sir. Paste it.
Just give
Also,
me.
so when will we get the practice and graded assignment solution?
See, practice graded assignment solution. I think week 1 is there. Week 2, I will talk to team so that they can upload it soon. And regarding practice assignment solution, there is no practice. I mean, no means if you will click on the choose, select answer, right?
Yeah.
So you will get the feedback below every question.
Sir,
Can you
but
try?
now solution are not there.
Yeah, so,
that-
but every term we were getting it last time we had the solution.
No, one second.
Yeah.
Okay, 1 minute.
No,
I
we got solutions for maths because there were some errors in the portal while
Okay,
submitting.
one second. First of all, I have pasted the PDF in the chat box. Everyone can access it. Can you check?
Yes, sir.
Fine.
Yes, sir.
Yes, sir.
Yeah,
Got it.
regarding practice assignment, let me give you a hint. See, if whenever you have this practice assignment 3.1, right? So it will, if you after each refresh, right, you will get the different set of a question. Okay, for practice assignment
Yes.
1. If you'll click on the check answers, right, then you can simply say the solutions are there below every question.
Okay, sir. So there is no graded assignment solution for even for the week 1.
No, week 1 is there. We had uploaded. Week 2, I think by mistake team has not uploaded. I will ask to the so that they can upload. If you click here, week 1 is there, right? You can check. Can you cross check?
So
Yes, sir.
Okay, it's there. Okay.
not there. Acha, in the supplementary content.
Yeah. So see,
Okay.
the PDF practice assignment solution and all peer deck links and all you can get under the supplementary content. Also, one more thing is there. Let me share my screen. You can refer. That will help you a little bit if possible. So you can go to under supplementary content. There is one textbook. Have any one of you seen this?
Yeah.
Okay, so this textbook is just it's basically content of with some different examples for with till week. So there are content of week 1 to 6, 7 to 12 also. So if you see, so this is something whenever you want to revise, right? You can do the revision itself, right? So like sample population from the very first week. Okay, this is basically our content. You can refer this one also, right? Okay.
Yes, sir.
Okay, fine. So everyone is able to access from this PDF which I have pasted on the chat box.
Yes, sir.
Yes.
We all
Whole
right? Okay. Okay, then I think we can wind up. If,
So let me
Sir,
download
Sir,
PDF.
excuse me, sir.
Yes,
I have
sir.
a doubt. I have
Yeah.
doubt from 3.1 fifth problem, sir. 3.1. Can
Yeah, one second. 3.1 activity.
yes, sir.
Activity 3.1, right? You are talking about?
Yes, sir.
Okay, what is doubt?
Fifth problem.
What is the fifth problem? Okay, what is the class mark of the class interval? This one. Hello.
Yes, sir. Yes, sir.
So class mark, we have discussed class. Okay, how did you compute the class mark? Tell me. Yeah, I mean, how did you approach? Just tell me, Malli, then I will be able to know. where you have made mistake. Yeah, please go ahead.
Sir, actually that marks is there, na sir. I took them as class intervals.
Okay, so basically
That
class.
x-axis.
One second. I think you have taken the some this marks, right?
Yes,
50
sir.
to some 40, 49 something.
Yes,
No,
sir. Yes, sir.
class mark doesn't mean here marks of this thing. See, I think you have joined session late, right?
Very late, sir. Very late.
That's right.
1
No
hour
problem, no
later.
problem, no problem. So class mark of any interval has been defined as the average of the limits actually. Class mark is the another definition. It's not about marks of students. Okay. So it's the average of the limits. Okay. Suppose you have interval a comma b, right? So what will the class mark for this interval? It will be a plus b divided by 2. Okay. So if you see
Yes, sir.
in this case, class mark of interval 55 and 60. So average of 55 and 60. So it will be 55 plus 60 divided by 2, which is 57.5. Is this clear now?
Yes, sir. Thank you.
Yeah.
Similarly, second question.
Second means sixth or question number 2?
Question number 2.
Okay. What is your doubt? Yeah. So it's yeah. Good. What is your doubt exact? I mean, you are not able to approach, or what was your approach? My question is.
Sir, I did not get the answer range 17, 18. Actually, I
Okay.
got some 45, something like that.
How?
So
Yeah,
how
tell
much
me.
percent?
Yeah.
How much
How did you
percentage
approach?
of?
Yeah. So it's a okay. What is the frequency for class 1 and 25, right?
5. Yes, sir.
What is the 20 to 40? 10. So what is the
10.
total? Total is 5, 10, 15, 6, 21, 8, 29, 6,
40,
35.
I think.
Sorry,
Total
35,
40.
right?
35. Yeah, 35.
Right. So okay, what is the thing? I mean, what is the frequency for class 40 to 60?
6, sir.
So how will you compute the percentage?
6 by total frequency.
And now just do it, whether you will get or not. Just tell me. 6 by 35 is how much?
6 by 35.
Sir, 0.1714.
0. Yes, sir.
Now you got
Yes,
it?
sir. Yes, sir.
Clear?
Okay, sir.
Fine.
Thank you.
Yeah.
Sir, can you give access to FAQ sessions?
FAQ was taken by
Recording.
TAs.
Yes, sir.
When the session happened?
So in 5th Feb and I think 7th Feb.
Okay, let me just give me a minute. I think for the 5th Feb there was okay, morning session you are talking about, right?
Yes, sir.
Okay. Yeah, it's yeah, viewer access is there. Can you check? I have given.
Okay,
Can you
sir,
check?
I can check.
Yeah, please check. You can check and tell me whether you got or not.
Sir, is this session recorded?
It's live on YouTube.
Okay.
Did you get it? As in Diksha, right?
Yes, sir, get
Got
it.
it? Okay. Yeah. Okay. Sorry, Disha. Okay, then. Thanks all. We'll meet in the next session. Okay. Hope you got the points which we have discussed.
Thank you, sir.
Thank
you.
you.
Yeah.
Good night, sir.
Good night.
Thank
Good
you,
night.
sir.
Bye, everyone.
Thank you, sir. Good night.
Bye.